This really is a pretty interesting question, if head injuries affect divorce rates. So as you read this paragraph, remember we're looking for information about what we need. It says we need to construct and interpret a 99% confidence interval for the difference between divorce rates. And divorce rates, that's a percentage or a proportion. So what we're looking for here is a confidence interval for a proportion. That's an important thing to notice. The other thing you'll notice is that there are two samples or two populations involved. Those groups in which there was a head injury and those in which there was no head injury, or what we would call the general population. So we might want to collect our sample data here relative to their two groups, population 1 and population 2. So as we read through this, let's sort of take inventory of what we know. First, it says that of 51 couples married, so 51 is the first population size. You see that that's those who had a head injury, so it belongs in that group. 20 of them are still married. 20 married. Of 50 randomly selected couples with no head injury, so second population sample size is 50, 24 are still married. Now we construct and interpret a 99% confidence interval for the difference in divorce rates. So what we're trying to find from these samples are divorce rates. That's a percentage or a proportion. What we have, though, are data on how many people were married. Now, since this is binomial, you're married or divorced, we'll assume. If 20 of 51 are married, that means that 31 of those are divorced. From this, we can make our first sample proportion. The proportion or the divorce rate among those with a head injury is 31 out of 51. So let's pull up this bad boy, find 31 out of 51. 0.6078. Same thing for the second sample data. We have a number that were married, so we can take subtraction. 50 minus 24 means 26 people were divorced. That creates a second sample proportion. P had a divorce rate for those without head injuries of 26 divorced out of 50 in the sample. 26 out of 50 is 0.52. From this information, the sample proportions from the two samples, we can create the first thing we need, which is the point estimate. Remember, point estimate is the best guess we have for this thing we're trying to estimate, the difference in divorce rates. So if we have two sample divorce rates, we simply need to cook up the difference. What's the first minus the second divorce rate? What's the difference between these two from the sample? That's 0.6078 minus 0.52, or a point estimate, a best guess for this difference of 0.0878 to 4 decimal places. So that's our best guess. Now the next thing we have to find is the margin of error for this confidence interval. That takes some thinking, some decision we must make. Which formula should we use? What are we trying to estimate? What are the parameters there? Let's look at the formula sheet. We're doing two samples. We had head injury and no head injury. We're making difference in divorce rate, so it must be this one, which has the following margin of error. We've already made our p-hats, divorced out of sample size, so now we just need this margin of error. The error formula that's appropriate is a critical value of z times the square root of p1 hat times 1 minus p1 hat over n1 plus p2 hat times 1 minus p2 hat over n2. So the only thing that's missing from this is the critical value of z, and that comes from our confidence level. So if our confidence level is 99%, 0.99, We use the summary table that was provided at the beginning of the node outlines, or just Google it. It's a critical value for 99% confidence. It gives you a critical value of 2.58. So it's a simple substitution. Let's plug those numbers into this formula and cook up the margin of error. Once we plug those numbers in manually, it looks like that. And punching it into the calculator, I'd want to be the most accurate that I can. So if I take this 31 out of 51, that was the largest decimal place I need to mess with, and punch it in one more time, then on my next line I can call it back using the answer function. So instead of typing 0.6078 yada yada, I'll just do second answer times 1 minus second answer, and then divide by 51. That saves me some typing. 0.52 isn't such a big deal, so plus 0.52 times 1 minus 0.52 divided by 50. So we see they have the sample proportion over the appropriate sample size, which matters, and very importantly, the correct value of the critical value of z. Make sure everything's under the radical, so if your calculator doesn't have the function where the radical keeps going over and it opened a parenthesis here, just make sure you close it down here after the 50. The correct margin of error is 0.2536537,438. That's all the decimal places the calculator gave me. I think web work, your homework, most places you need to be accurate to about 6 decimal places and round at the final answer. How do we get to that final answer? Third step of a confidence interval after we cook up the margin of error is to just add and subtract to find the lower limit and the upper limit. That's your point estimate, or your best guess for the difference between them. That's under my calculator right now, but I see the answer up there, 0.0878 minus this margin of error, 0.25365 yada yada, or the same values but added, 0.0878 plus 0.25365. So in the calculator I can scroll back up, grab this 0.08 number, that was our margin of error, subtract, 0.08 was our point estimate, subtract the margin of error for negative 0.166 to 3 decimal places, or take that statement and change it to plus. For 0.341 to 3 decimal places. So our confidence interval has a lower limit of negative 0.1717% and an upper limit of about 34% is the difference between divorce rates. So can we claim any difference? Not by this sample. The confidence interval contains the value of 0, right? 0 would be in here, somewhere between negative and positive. So we really can't claim that there's any discernible difference in divorce rates based off of this sample, since it's possible for the difference between the divorce rates, P1 minus P2, could possibly be 0, because 0 is on this interval. So maybe there's no difference in divorce rates. I can't claim that one's higher than the other since the interval contains 0. So we are 99% confident that the true difference in divorce rates between those with a head injury and those without is between negative 0.166 and positive 0.34.